Okay, guys, let's go over writing word problems and solving literal equations. So here is our first word problem. It says Crystal is 12 years less than twice as old as Lori. Grant is 18 years more than half as old as Lori. The sum of their age is 83. So we're going to write a formula, and this is our keyword in our formula. So we have Crystal's age plus Lori's age plus Grant's age, and the total is 83. Now we know something about Crystal because it says Crystal is 12 years less than twice as old as Lori. We know something about Grant. Grant is 18 years more than half as old as Lori. We know nothing about Lori, so we're going to let X represent Lori's age. Now we're going to use this X to write an expression to represent how old Crystal is. Well, she's 12 years less than. Less than is one of those flip-flop phrases. So 12 years less, that's going to be minus 12, and twice as old as Lori is going to be 2x. For Grant, he is 18 years more than, so more than the phrase than, any than is going to be a flip-flop. So we're going to flip the plus 18 behind half of Lori. So half x plus 18. Now we're going to use the formula to replace the words Crystal, Lori, and Grant with their algebraic expression. So Crystal, 2x minus 12, plus Lori, x, plus Grant, 1/2 x, plus 18 equals 83. Now we're going to collect like terms and solve. So I have 2x plus 1x plus half x. So that's 3 and 1/2 x. Then we're going to combine minus 12 plus 18. That's going to be plus 6 equals 83. We're going to solve for x by subtracting 6 from both sides. And we have 3 and 1/2 x equals, and this is going to be 77. Now we are going to divide, so I'm going to rewrite this into an improper fraction, but remember you can use a calculator in this unit. And so we're dividing by 3.5, or we could say this is 7 halves x equals 77 because it was 2 times 3 plus 1 to get 7 halves. Now when I divide by 7 halves, that's the same as multiplying by its reciprocal. And on both sides, hold on, So now I can either multiply straight across and then divide, or I can divide and then multiply. And I like to do that when the denominator can divide into the whole number, and that's 11. And then now I multiply it by 2, and x equals 22. So we take that and we plug that value in everywhere we see x. So Lori is 22. Crystal is 2 times 22 minus 12. So 2 times 22 is 44 minus the 12, and I get 32. So Crystal is 32. Grant is going to be, excuse me, half of 22 plus 18. So half of 22 is 11 plus 18 is going to give us 29. So that is all the ages that would add up to 83. The width of a rectangle is 8 more than half the length. The perimeter is 88. So remember that perimeter is adding all the sides of a shape. And so with a rectangle, we're going to have 2 lengths to add plus 2 widths. So when I write my formula, I'm going to say 2 lengths, parentheses is important, plus 2 widths is equal to 88. So the width of a rectangle is 8 more than half the length. The part I know nothing about is length, so I'm going to let that be my single x. Now let's take x and use it to write an expression to represent the width. It is 8 more than, so that's a flip-flop, so that flips to behind half the length. Half the length is half x. Now use the formula to write the equation. I have a 2, and instead of length, it's x plus 2 times width, and width is half x plus 8 equals 88. Now I'm going to distribute and solve. 2 times x is 2x plus 2 times 1/2 x, or half of 2, you can look at it that way, is 1x. 2 times 8 is 16. We're going to combine our like terms and get 3x plus 16 is equal to 88. We're going to subtract 16 from both sides, and we have 3x is equal to 72. We're going to divide by 3, and x is equal to 24. X is the value for the length, so the length is 24. The width is half 24 plus 8. Half of 24 is 12, plus the 8 gives us 20. So the width is 20 and the length is 24. And if we were to add 24, 20, 24, 20, we would get 88. Okay, now let's take a look at this problem. Josh charges a diagnostic fee of $50. He charges $30 an hour to fix the issue, where Jacob charges $20 an hour with a diagnostic fee of $100. So a diagnostic test is just where you, so let's just pretend these Josh and Jacob are mechanics, and they will test your car. They will plug it up to a computer just to see what the problem is, and that's the diagnostic fee. Then you also have to pay $30 for each hour that Josh works on the car, or for Jacob, his is $20 an hour. So the question is, at what hour will they charge the same amount? And what is the amount? So let's let x be hour. So the formula is going to be, at what hour does Josh's cost equal Jacob's cost? To represent Josh, he has a $50 initial fee plus a $30 an hour fee, and x is hour. So we have 30 times x plus the 50, where Jacob is 20 an hour. Girls, sorry, my doggies are wanting to play around. $20 an hour with a $100 diagnostic fee. So now use the formula to write your equation. So for Josh, we have 30x plus 50, and Jacob is 20x plus 100. When you have variables on both sides, you need to address the variable before the constant. So don't subtract out 50 or 100. Deal with the variable terms. I like to move the smaller one, so I'm going to subtract out the 20x. This leaves us 10x plus 50 equals 100. Now we can just solve by subtracting out the 50. We have 10x equals 50. Excuse me, we divide by 10, and x, hour, is 5. So the question is, at what hour will they have the same amount? Well, hour 5. So at hour 5, they will have the same amount. And now we need to write out what is the amount. So we're going to plug in 5, and really you can just plug it into either one, but I'm going to go ahead and plug it into both just to verify that my answer is correct. So this amount should be the same. And we see it is 30 times 5, so that's 150 plus 50 is 200. 20 times 5 is 100 plus 100. Again, I get 200. So at hour 5, they each will charge $200. That is the only time that they will charge the same amount at that hour. Okay, let's do just a few literal equations. Remember, literal equations just have more than one variable. We're not going to actually get an actual value. And all we're doing is moving all the other numbers and variables to the other side, leaving the p by itself. So whatever variable you're solving for, everything else has to move over. So what is happening to p? So if, let's just go through order of operations. P is being multiplied by 3, then it's being divided by c, and then it's being added with d. So we're going to undo adding, dividing, multiplication. So we're going to undo addition and we're going to subtract d. Now remember, when you add or subtract, it comes after what's already there. So the p needs to be in front, q minus d. Now we need to undo the division by multiplication. And yes, we have to have parentheses here. So that cancels the C. So C times capital Q minus D, close parentheses. Now we need to undo multiplication by division. So I'm going to divide both sides by 3, and P is now isolated and solved. Excuse Lola and Lucy. So here is your answer. Okay, we're going to isolate P again, but it's a whole new problem. P, so first, let's undo that. Hold on. I just want to write down the operations. P is being squared, then it's being multiplied by 4, and then it's being divided. So that is, if we knew the variable, if we knew the values, that's what we would do. So we're going to work backward, and we're going to undo the division by multiplying. We're going to undo multiplying by division, and we're going to undo squaring by the square root. So let's multiply by C. I don't need necessarily a parentheses here because there's only one single term. So I have 4p squared equals, and you can say CQ or you could say QC. Commutative property here, that does not matter. Now we are going to undo multiplication by dividing by the 4. And I have p squared equals CQ over 4. Now we're going to undo squaring by taking the square root. When you take the square root, that undoes an exponent of 2. So now p is by itself. And when I take the square root of this side, you do need that plus or minus out front, just because when you take the square root, there are 2 roots. So here is your final answer. Okay, we're going to do 1 or 2 of these where we are getting ready for our linear function unit. So we're learning to solve for y to get it in slope-intercept form. So y, we have 2 terms here, 6x minus 2y. Y is within this term, so the first thing is we have to move this term all together. So we're going to subtract 6x. Notice that I do not put the minus 6x under the 8 because these are not like terms, so I'm not going to line them up. I'm going to bring down negative 2 times y equals 8 minus 6x. And this time when I divide, I'm not going to do just one big long division. Every term is going to be divided by the negative 2. That's going to help me make sure I get my signs correct. So y equals, this is negative 4. Negative over negative is positive, and that's going to be 3x. Now, you can leave it this way, but I'm always going to write my variable term first, like this. Okay, let's do this last one. Again, we are isolating y. We have 2 terms here. Since we're isolating y, we need to get this term all together on the other side. So we are going to add 9x to both sides. So I'm going to add 9x. We're going to bring down negative 12y equals negative 24 plus 9x. We're going to divide, because we are undoing the multiplication, every term by negative 12. Y equals, so this is going to be a positive 2. A positive divided by negative is negative, and I'm going to just simplify this. 3 can divide into both 9 and 12. Oops, well, let's divide that out. So that should be 3 over 4, so minus 3 over 4x. I'm going to rewrite it so that the x term is out front, and this is a plus 2, positive 2. So I hope this helps.